Hello and welcome. In today's class, we'll be looking at the CardGame stack program that appeared in ISC Computer Science 2024 theory paper. So according to the question, we have a card game, which is a game of mental skill built on the simple premise of adding and removing the cards from the top of the card pile. So when we read this statement is indicating that we require a stack here, the stack data structure, because it is clearly stating that adding and removing can only be done from the top. So it is following the LIFO principle, last in, first out. These are the details of the class. Class name is CardGame. Then we have an array to store integers, cap to store the maximum capacity of the array, top to store the index of the topmost element of the array. Then we have a constructor to initialize the capacity, the top, and we also have to create an array here. Then add card is allowing us to add data to this stack, whereas draw card is allowing us to remove data from this stack. And then we have the display function to display all the values that are currently there in the stack. Obviously, if the stack is already full and we attempt to add new data to it, it will display card pile is full. Similarly, if the stack is empty and we attempt to delete an element at that time, then it will return an uncommon number -9999. So in this question, it is told to write the functions add card and draw card only, and we need not write main function, and we have to assume that rest of the functions are already defined. But to check the output of this program, we need to write the full program. We need to include all the functions. We need to include main. That's why in this video, we'll be writing the full program. The second part of the question asks, name the entity described above. The entity is stack because it is following the LIFO principle. So it is asking for the principle also, state its principle. So the answer is LIFO principle, last in, first out. So that's the question. Let's start writing the program. So here I have created a file cardgame.java. Let's start writing the program. So we start with the import statement. We create the CardGame class. Now we include the data members. So we have an array. Then we have a variable to store the capacity and to store the index of the topmost element. Then we have a constructor. This is a parameterized constructor. We pass the capacity. So capacity equals this value. Then once we have the capacity, we can create the array now, the array object. So new int capacity. And top will be initialized to -1. So -1, this value indicates that the stack is initially empty. Next, we have add card function. So here we will be passing the value that we need to add. So if top plus 1 means if we add 1 to the value top or the variable top, and if this happens to be equal to the capacity, what does it indicate? This indicates that the stack is already full. So in that case, insertion is not possible. The push operation is not possible. So we print card pile is full. Else, otherwise insertion is possible. So cards, we firstly increment the value of top and then use that value as an index, and we store the value. So that's why we are using pre-increment here. Firstly, top increments, then in that location. So from -1, it becomes 0 first. Then in that index, the value gets stored. So that's the add card function. Similarly, we also have to create draw card function. So public int draw card. So here the return type is int because it's going to return the value that was deleted or that was removed. In case deletion is not possible, then it's going to return an uncommon number -9999. So if top is -1, that means deletion is not possible. The pop operation is not possible in the stack. So we return -9999, else we return cards top minus minus. So here we are doing post decrement because first of all we want to delete the current element and we want to return that current element, and then we want to decrement the top later. So that's why post decrement. And one more thing, we can omit this else part because we are using return in the previous line. So else is of no value here. So we can directly write, because this statement return -9999, this will only work when this condition is true. Otherwise, automatically the last statement will execute. And then we have the display function, which will display all the elements currently stored. So once again, here we need to check if the stack is empty or not. So if top is -1, then in that case, we cannot display any data. So system.out.println, we can print card pile is empty. Otherwise, so for I equals top, I greater than equal to 0, I minus minus. Now if I is equal to top, in that case we print cards I plus and one arrow with a message top. That means it will indicate that this particular value is the topmost value. Else system.out.println cards I. So that's our display function. Now we only need to create the main function. So we create the main function, and in this main function we will create the scanner object first of all. Because here first of all we'll be asking the user to enter the capacity of the stack. So we give a message to the user. So system.out.print, let's say card pile capacity. So I'm taking it in a variable C. So once the capacity is taken from the user, now we can create an object of this class. So CardGame obj equals new CardGame, and we pass the value C. And we run an infinite loop and display a menu to the user. So system.out.println, let's say add card. This is the first option in the menu. Then the second option, draw card. The third option, display cards. And now we ask the user to enter the choice. enter your choice. So we take it in a variable choice, int choice equals integer dot parseInt in dot next line. And now we use the switch statement and we put the choice inside switch. Case 1. Now case 1 means the user wants to add a card. That means we need to ask the user to enter the data that needs to be added. So we ask another question to the user. Let's say card data. So int d equals integer dot parseInt in dot next line. Now through the object we call the add card function that we had created earlier, and we pass the data that we need to add, and then we break out of switch. Then case 2. In case 2, I receive the value after deletion. So obj dot draw card. Now if the value of d is minus 9999, that means deletion wasn't successful. So we can print card pile empty. Else we can print d removed, and we apply the break keyword. Case 3 means display, so obj.display and break, and any other value means default. In that case we simply print a message, let's say buy, and then we call the return keyword to exit from main, and automatically the program will terminate because main will terminate. So we have completed our program. Let's check the output now. So it is asking for the card pile capacity. Let's give 5. Now it is displaying a menu. Out of these options, suppose if I want to draw a card, let's say I choose option 2. So it is showing me that card pile is empty. We cannot draw a card right now because the stack is empty. So let's give option 1. So it is asking for the data to be entered. So let's say 23. Then if I enter option 3, then it is showing that 23 is the topmost element right now. Then again I add more data. So this time I want to enter 45. Then again I want to check. So you can see 45 now is the topmost element, and then later we have 23 below. And again if I add, now let's say I want to enter 78. Again I check. So this time 78 has become the topmost element. And then I, let's say, want to delete. So if I choose option 2, so 78, the topmost element got removed. And once again if I display, now again I have only 2 elements left. And if you choose any other option, let's say option 4, the program will stop. So I hope you have understood how to solve this stack-based program. If you still have questions, you can get in touch with me through comments. Thank you for watching and see you soon in the next class.